All right, let's jump right in. For decades, manufacturing has been stuck playing this game of catch-up with quality, right? You're always trying to find defects after they've already been made. But what if we could just stop playing catch-up altogether? Today, we're going to look at a totally radical shift, where AI and robotics aren't just finding mistakes, they're helping build a whole new philosophy of quality from the ground up.
This quote from the absolute legend W. Edwards Deming, it just hits the nail on the head, doesn't it? The traditional assembly line always ends with some inspector. But by that point, the money, the time, the material, it's already been spent. You can't inspect quality into a product. It has to be built in from the very start.
And look, this isn't just some abstract philosophical problem. It has a very real and honestly, a pretty shocking price tag. Check this out. What's so wild about this is how a tiny, seemingly insignificant error, like overfilling a box with just one extra 9-cent bracket, completely snowballs into a $45,000 loss over a single year. This is the hidden tax of poor quality, and believe me, it is happening on factory floors everywhere.
So this all leads us to what I like to call the inspection paradox. For years, we've relied on human inspectors, or maybe some random spot checks, but the entire process is reactive. It's designed to catch failures after they happen, which is, when you think about it, an incredibly expensive and inefficient way to guarantee quality. You are literally paying to find your own mistakes. It's a losing game. And here's the kicker. This cost isn't just the price of a wasted bracket. The cost of poor quality, or COPQ, is a lot like an iceberg. Above the water, you see the obvious stuff, scrap material, the labor costs for rework, but it's what's below the surface that's truly dangerous. Customer returns, massive penalties, and maybe the worst of all, the slow, silent death of your brand's reputation.
Okay, so if the old way is a losing game, what does the winning strategy look like? Well, it looks like this: a tireless, hyper-accurate inspector that can see, think, and learn. So let's break down the anatomy of this AI inspector.
And here it is, the hero of our story. This is a system designed for inspecting really complex automotive parts, and it's built around 3 key things. First, you've got a high-resolution camera that acts as its eye. Second, you have this specialized lighting that gets rid of all the glare and shadows, making sure you get a perfect view every single time. And third, a collaborative robot, a Cobot, that just gracefully moves the camera into position with superhuman precision.
And this just shows you the whole workflow. It's like a simple, elegant 3-step dance. The Cobot scans the part, putting the camera over every single critical point. The vision system sees, capturing a crystal clear image, and then the AI model thinks, analyzing that image in milliseconds to spot tiny defects that a human eye might miss even on its best day.
But wait, how does the AI actually know what a defect looks like? This isn't magic. It's a super rigorous training process. You have to teach the machine to see not just what's there, but what shouldn't be there. This is really where the intelligence of the system is born. Now, training an AI inspector means you have to overcome 2 major types of errors. On the left, we've got a false negative. That's a real defect that the AI completely missed. That's the really dangerous one. Then on the right, you have a false positive. That's a perfectly normal feature that the AI incorrectly flagged as a defect. This just slows everything down and causes unnecessary work. The goal, obviously, is to get both of these numbers as close to 0 as humanly or, artificially possible.
And this chart really tells the story of that journey to perfection. The researchers started with a standard model, which was pretty good, but you see it still missed one defect. So then they tried a different technique, which, eliminated the missed defects, the false negatives, but it created a whole bunch of new problems with false positives. So the breakthrough, the crucial point, was the final step. They combined the strengths of multiple models into what's called an ensemble. And the result? Just look at that. 0 missed defects and only 2 false positives. That is absolutely world-class performance.
But here's the thing. This is about so much more than just a really cool robot. Having a near-perfect inspector changes everything. It lets you make a fundamental shift in how you even think about quality itself, moving from being reactive to being proactive.
So what you're seeing here is a continuous feedback loop. The system isn't just sorting parts into good and bad piles. No, it's collecting precise data on every single defect. And that data is then used to make the AI smarter and the entire manufacturing process more reliable with every single part it inspects.
This whole system is what enables this powerful concept called quality by design, or QBD. The core idea is actually pretty simple. You don't wait to test for quality at the end. You design your product in your manufacturing process to produce quality results, consistently, from the start. You build it in, you don't inspect for it.
And this slide just puts the 2 philosophies right next to each other. The old way is totally reactive. You find a bad part, you throw it out. The new way is proactive. You understand your process so well that you just don't produce bad parts in the first place. One is about catching failure, the other is about designing for success. It's a night and day difference.
And the benefits? Oh, they're massive. We're talking fewer failed batches, huge cost savings, incredible consistency from one product to the next, and a dramatic reduction in the risk of a catastrophic, brand-killing product recall. You gain true, actual control over your entire manufacturing process.
And that brings us to the real game changer here. The most valuable thing this AI inspector produces isn't a pile of good parts and bad parts. It's the data.
What's so amazing about this is that the AI isn't just giving a thumbs up or thumbs down. It's acting like a scientist. It's measuring the exact size of that surface scratch, down to the millimeter. This data is absolute gold. It tells you not just that a problem exists, but what the problem is, where it is, and how severe it is. You can use that information to go back up the line and fix the machine that's causing the scratch in the first place. And that is how you stop inspecting for quality and start building it right in.
So, I'll leave you with this thought. If quality is no longer a job for a person at the end of the line, but it's an automated, data-driven function that's built into the very fabric of the process itself, what does that enable? What does that factory of the future, built on a foundation of perfect data, truly look like? That's definitely something to think about.